We were talking about different sampling schemes last time. We went through a whole bestiary of different ways of drawing samples. We're now going to focus on a couple of the simplest ways of drawing a probability sample. So our big dividing line, the big bright line, is between probability samples and non-probability samples. And in non-probability samples, we have things like samples of convenience, quota samples, systematic samples, so forth and so on. In probability samples, we have a wide variety of things, the simplest of which is a simple random sample, which is it's like putting a ticket for every individual in the population into a big hat, stirring up the tickets really, really well, and pulling out little n tickets from the hat that contains big N tickets without replacement. Now, I should maybe mention in passing that that's actually a terrible way to draw a random sample, that to put tickets into a hat and try to stir them up, or to put ping pong balls with labels on them into a big bucket and stir them up is really not a very good way to do it. The reason being that it's very difficult to mix things thoroughly mechanically. And this actually came up in the Vietnam draft lottery, that people's names sort of went into the hat and they ended up not getting stirred up very well. And so if I'm remembering correctly, if your birthday was towards the end of the year, you were much more likely to be drawn in the lottery because those were the names that went in last and they didn't stir things up very well. So physically randomizing things is hard. What we do in practice and statistics might be to generate a random seed by rolling dice or tossing coins or using something like that, and then from that random seed to use a pseudo-random number generator, an algorithm that produces a sequence of numbers that behave very much like random numbers, but not exactly like random numbers. They are, in fact, predictable. There's an algorithm that's used to generate them. So if it ever falls to you to draw a random sample, you probably don't want to do it by putting names on tickets and putting the tickets in a hat and stirring them up, just because it's very difficult to do that in a way that ends up being fair. It's also very difficult to verify that there's exactly one ticket for each person in the population, for each item in the population in the hat. If you're going to do it using a pseudo-random number generator, you want to avoid using things like Excel. Excel's random number generator is broken. You want to be careful to use a high-quality pseudo-random number generator, and if that ever comes up, then you can start, look for things like the Mersenne twister algorithm. There are other things that are very good as well. Anyway, all right, so on the side of drawing probability samples, we have a simple random sample. We have random samples with replacement. Both of those have the feature that every item in the population has the same probability of being selected. Systematic random sample, every item in the population has the same probability of being selected, but not every subset of the population has the same probability of being selected, right? So it's simple random sample has the distinguishing characteristic that every subset of little n of the capital N objects in the population is equally likely to end up being the sample. We talked about cluster samples, multi-stage samples, stratified samples. There are random versions of all those, stratified random samples, so forth and so on. We're just going to concentrate on the simplest cases, which are simple random samples and random samples with replacement.